Hi guys, today I will tell you about the software system for the Mars and Mars mission sampling and catching tables. It means then what is the software system in the space mission to travel to Mars in 2020 and 21. The development for the sampling and catching subsystem of the Mars 2020 rover mission is highly dependent on testing of prototype hardware and software operating in explicit conditions as part of integrated test beds. To achieve relevant integration of hardware and software while maintaining rapid algorithm development capabilities and a high testing throughput, the controls and autonomy for sampling acquisition and handling software system was developed. Cache is an implementation of the intelligent robotic system architecture which mimics JPL flight software in that it is divided into modules that run separately, processes that communicate via message passing. Each module is assigned an owner that is a single developer, and the operator initiates request via the text-based interface that interprets sequences of commands. IRSA enables a modular breakdown of cache that follows that of 2020 flight software, as developers can take an algorithm from a model in cache and re-code it into the same module in FSW. As deployment of cache has grown to test to 10 beds, each with different hardware and objectives, bottom-up design decisions have been initially made to keep the system lightweight and maintainable by a very small team. To date, cache has been used to run 13 and 93 different tests. This work describes cache, the test beds and functionality. It supports the tools used to manage the development and sharing of code, and that features of the software. Lessons learned over the past 3 years of development and deployment are provided. The Mars 2020 rover mission, sent to a launch in July-August of 2020, is part of NASA's Mars exploration program and is being managed by the Jet Propulsion Laboratory. The mission consists of a Mars Science Laboratory heritage rover with a new payload that addresses high priority science goals for Mars exploration, including key questions about the potential for life on Mars. One of the 4 objectives of the mission is to collect marine sample cores and deposit them on the surface for potential returns to each by a future mission. This capability is to be achieved via the sampling and catching subsystem, which is currently under development. The sampling and catching subsystem consists of a rotary pursue corning drill for collecting sampling, robotic arm for tool placement, a system for managing drill bits, and sample tubes known as the adaptive catching assembly, and gas dust removal tool for clearing rock obstructions. Development of SCS hardware and software requires prototyping and testing, which is achieved through test beds. Development test beds are integrated systems which consist of mechanical hardware, avionic, and software designed to operate in explicitly defined conditions in order to gather data required to refine and characterize the prototypes under test. An example of such a test bed for SCS is the environmental development test beds, which consist of a robotic arm and a prototype coring drill in a 10-foot thermal vacuum chamber. The high level driving requirement for the software system for these test beds are as follows. Number 1. Enable high throughput test for prototype hardware across a suitable of test beds. Number 2. Provide a framework for rapid algorithm development that can be tested on real hardware and assist with the flight software. Number 3. Allow for non-developers to operate the test beds. Number 4. Collect data products that can be easily pursued and achieved. Number 5. Provide robust fault protection to avoid hardware damage. Development of operating off-flight software is a complex region. So thank you so much.